Welcome to Study Loop.
So in this problem, we have to find out or calculate the Ksp value of the magnesium hydroxide, which was added in excess as solid and shaken with 1 liter 1 molar solution of ammonium chloride. So the Ksp uh, expression for magnesium hydroxide will be just the product of its two ions, that will be Mg2 plus concentration times OH minus concentration, and since we will have 2 OH minus in the dissociation, we'll have a square. So magnesium hydroxide will be dissociated as Mg2 plus 2 OH minus. That's why we will have the Ksp expression for MgOH2 as this. So here we have to know the concentration of magnesium ion and the concentration of the hydroxide ion to find the Ksp value of the MgOH2. So let's first find the concentration of magnesium ion, and for that we have to know that how much ammonium ion was actually um, dissociating in addition of the magnesium hydroxide. So the ammonium ion here, or from the ammonium chloride, it will be dissolved, or will be dissociated in water according to this equation. So it will be H3O plus NH3. And then if we set up an ice table for this, so the initial concentration of ammonium chloride is the initial concentration of ammonium, because from 1 molar ammonium chloride we will get 1 molar NH4 plus. So the initial concentration of NH4 ion is 1, and we don't need to consider H2O since it's a liquid. It will not have any effect in the equilibrium constant expression. And then our H3O plus, what is our initial H3O plus concentration? Initially we don't have any NH4 ion dissociated. That means initial concentration for H3O plus will be 0, and also the initial concentration for ammonia will also be 0. Now if we consider that x molar ammonium ion is being dissociated in presence of magnesium hydroxide, then in the equilibrium we will have the NH4 plus ion concentration as 1 minus x. So this much will be dissociated from NH4 plus, and then what will be the H3O plus concentration? So at the resulting solution we have the pH as 9. That means pH 9 means, as we know, that pH is basically the negative log of H plus or H3O plus concentration. That means if we take in the other way, the H3O plus concentration is basically 10 to the power minus pH, and pH here is 9. That means it is 10 to the power minus 9. So, or it is basically 1 times 10 to the power minus 9. So this is the H3O plus concentration of this solution. So we write it here. This is our final H3O plus concentration, and the final NH3 concentration will be how much we are having of the NH4 plus ion being dissociated in water. So it will be X. Now if we set up the the equilibrium constant or the Ka value for this reaction, the Ka will be basically the reactant over product. No, the product concentration over the reactant concentration. That means H3O plus times NH3 will be over NH4 plus. And we know all the concentration values here. So, but we have to find out the value of X from this expression. But before that, we have to know the value of K. So we know the value of Kb for ammonium chloride. So the Kb for ammonium chloride is 1.76 times 10 to the power minus 5, and we can find the K for this reaction just by using the relation between K and Kb, where K is Kw over Kb, and we know the Kw value is 1 times 10 to the power minus 14, and we have the Kb value as 1.76 times 10 to the power minus 5. So the result here will give us the value of Ka as 5.68 times 10 to the power minus 10. So this is our Ka value. So we just put it here, 5.68 times 10 to the power minus 10 is equal to the concentration of H3O plus, which is 1 times 10 to the power minus 9, and we have the NH3 concentration as X, and in the bottom we will have 1 minus X. Now if we solve this equation, we will have the value of X as 0.36. So this is the concentration which we are basically having or getting dissociated from NH4 plus in presence of magnesium hydroxide. And as you know that NH4 plus will basically interact with the hydroxide ion. That means this X is also the hydroxide ion concentration that is reacting with the NH4 plus. And again, so from this hydroxide ion concentration we can get the magnesium hydroxide concentration, since from one magnesium hydroxide we will have Mg2 plus plus 2OH minus. That means for for 1 molar OH minus we will have half molar magnesium hydroxide, since for 1 molar magnesium hydroxide we can get 2 molar hydroxide. That means for 1 molar hydroxide we will have half molar magnesium hydroxide. That means if we just take the half of this value, that will be our magnesium hydroxide concentration. So the half of this 0.36 will give us the concentration of magnesium hydroxide, which is 0.18. And again, this since from 1 molar magnesium hydroxide we can get 1 molar magnesium ion, that means this is also the concentration of our magnesium ion. So this is our Mg2 plus concentration. So so we have already got our magnesium concentration. Now we have to find out our hydroxide ion concentration to find the Ksp value. So what is the hydroxide ion concentration is here. We can just find this easily by from the relation of Kw is equal to H plus and OH minus. Using this equation we can find the OH minus concentration, which is Kw over H plus. And as we know that Kw is basically 1 times 10 to the power minus 14, and H plus 7 concentration is, we have already calculated, 1 times 10 to the power minus 9, and from here we can find the OH minus concentration as 1 times 10 to the power minus 5 molar. Now if we just put this OH minus concentration and the Mg2 plus concentration in our Ksp value here, that means our Mg2 plus concentration here is 0.18 times 1 times 10 to the power minus 5, which is our OH minus concentration. And if we just solve this, we will get the Ksp value here, which will be 1.8 times 10 to the power minus 11. So this is the Ksp value for the magnesium hydroxide in this problem.